Hello and welcome to another video. Today we want to talk about some introduction to regression. More specifically, we want to identify how trend lines work in Excel and how can we understand and interpret them. Right. So I've got an example right here with me. I've got ad count in one column, and I've got sales generated based on the number of ad counts in the second column. One way to set up trend lines is to just select our data, go to insert, make sure you have what's called a scatter plot, right? You could choose any plot for that matter. I like to choose scatter plot because on top of this scatter plot will be my trend line, and it would make more sense to have a line passing through these scatter points, right? So I've got ad count on x-axis, sales on y-axis, and my data points are scattered here. Now I want to be in chart design. Go to add chart element, trend line, and I will choose more trend line options. So once I choose more trend line options, by default I will have a linear trend line. Notice these dots right here, and I could play along with how they look by going through these different options, right? But more importantly, I have this linear trend line which is capturing the trend of this data. It's going upwards, that's fine, but I would want to turn on the display equation as well as display r squared value on chart, the coefficient of determination, which is also telling me the goodness of fit, how good a fit this line is to these data points. Just out of habit, I want to uh, change this to black color, and I want to increase their font size to make it more visible. Okay, so notice this is my equation of this trend line. Okay, 172.48x minus 6766.7. That's the y-intercept. It's passing the y-axis on minus 6766. So this is my trend line, and that's a nice trend line. But I have more options here to choose the kind of trend line that I would want. So I could choose an exponential trend line, and as I choose different kinds of these trend lines, notice how their equation and their r squared, the goodness of fit, the coefficient of determination also change accordingly, right? So this is a goodness, how good a line fits or how good a trend line fits to my data. A higher value, it is from 0 to 1. So the closer it is to 1, the better a fit it is, right? So this is my exponential trend line. Notice there's an exponential equation. There's a linear trend line. Notice a linear equation. A logarithmic trend line, logarithmic equation. There's a polynomial trend line. It's a polynomial equation with it. And I could actually specify the order of polynomial too, right? So this is an order 2. I could increase the order of polynomial, order 3, and the equation changes accordingly. Then there's a power trend line. So it's x to the power of something. Then there's a moving average also. So I have these bunch of options. What I want your attention now to is for different data sets, we might have different best trend lines. For example, between exponential and polynomial, I can see polynomial has an r square of 0.93, exponential has an r square of 0.88, right? So a better fit is a polynomial in this case. It has a better goodness of fit. But the question we're trying to answer here is how good is the goodness of it in terms of the polynomial orders, right? So if I increase the order of polynomial, make it say uh, order 3, my r squared seems to increase, right? If I go to order 4, r squared further increased to 0.94, r order 5, 0.945, and order 6 hits an r squared of 0.97. Okay, so uh, understand that while yeah, so I just wanted to put that in one line. Understand that as I increase or decrease the order, my r square increases and decreases also. But would that mean that an order 6 polynomial is a better fit to this data than an order 2 polynomial, so to speak? For comparison, let me have order 2 right here, and let me also just very quickly make an order 6 polynomial at the same place. Again, select our data, insert, I'll make a new uh, scatter plot, have the scatter plot right here, go to chart element, trend line, more trend line options, and this time I know my trend line on a polynomial order 6 for comparison, and I also want to display r square and the equation And just out of habit, I want to color it black, make it more visible. Increase the font size just slightly. Okay, so there it is. This is my order 6 equation. And here I have an order 2 equation, right? Side by side. Let's make that comparison. Let's talk about that. Now, look, we could argue that the one in order 6, let's call this order 6 trend line. Let's call this order 2 trend line. Okay, so now let's talk about this. See, order 2 trend line has an r square of 0.93. Order 6 trend line has an r square 0.97. The goodness of fit is higher in order 6, right? So it is a better fit, and I could also visually see this also. The trend line seems to be passing through most of these points, whereas the trend line doesn't pass through all of these or most of these points. Some of these points are left out, they're spread on either side. Well, it is a goodness of fit line, so it tries to fit these points. While there is a better coefficient of determination or goodness of fit in order 6, it's important to recognize that order 6 trend line is not a true depiction of reality. It does not depict a real use case. What this is essentially telling me in order 6 is that if I increase my data points, if I increase my ads by just 50, would that mean my revenue or my sales are going to skyrocket? Would it be somewhere here? Because if we do this for predictions, right? We want to predict the next data point. And if you continue this line, it seems to be skyrocketing upwards. So by having 50 or 25 more ads here, would that mean my sales are going to skyrocket? Would that really be a realistic depiction? Well, it's arguable and it's not quite the case. Yeah. So, but if you look at this second order trend line, you realize that this is in fact a more realistic depiction of the trend of how the data points are scattered. And if I increase 25 more ads, my sales are going to be somewhere around here, which is more realistic. It aligns with the flow of my data points, right? So sometimes we could fall into trap of what's called as overfitting. Just by trying to have a better r square or better fit, we might end up fitting way too much, trying to pass through every single data point, that we end up in a scenario that is not realistic and does not make realistic predictions, right? So we would want to avoid that and carefully choose the order of polynomial in our trend lines in such a way that they might sacrifice some goodness of fit, but will be closer to a realistic scenario, such as in this case, where second order is closer to the order 6 polynomial. I hope this makes sense. If there are any questions, happy to address them in the comments section. Thank you. I'll see you in the next one.